Be sure to put your name and your date on your notes today. Today we are doing lesson 2.1, scientific notation. I will tell you that this is pages 33 to 38 in your book. Your essential question: how can you use scientific notation to express very large quantities? We have several vocabulary terms today. So let us start. Scientific notation is a method of expressing very large and very small numbers. As a product of a number greater than or equal to 1 and less than 10, and a power of 10. I'm going to write this another way to take these words right here and see if we can make better sense of them. We're going to have a number that is greater than or equal to 1, and in this format, because now I'm going to say that it's less than 10. That's how we read that. We have a number that is greater than, because it's open to the n. So that means that's greater than or equal to 1 or less than 10. And it's multiplied by a power of 10. I'm going to keep going. Standard notation is my next one. a number written as we would normally write it without any shortcuts. Then we have power. Power is the number produced by raising a base to an exponent, which probably means we need to talk about base. And the base in an exponential expression is the number that is used as a factor which is repeatedly multiplied. And I'm turning the page. Our next word is exponent. The exponent is the number that indicates how many times the base is used as a factor. Now, to write a number in scientific notation, especially a very large number, which is the foundation of this lesson, the process is actually explained in your textbook in one version on page 33. So I want to talk about the process, and I want to mention in my notes that it is explained on page 33. So I know one place that I can go and get this explanation. Let's start with a gray whale. Which weighs 68,000 pounds. And we want to write 68,000 in scientific notation. So first of all, I'm going to rewrite that number. And I want to think about placing my decimal to the right of the first non-zero digit, which if I look at my number, I've got 68. And if I'm going to write this, I'm going to take 68 and I'm going to write it down. I'm going to put my decimal right there to the right of the 6. Now I know this has to be multiplied because of my definition by a power of 10. And so I'm going to find my power of 10 by counting the number of places moved from the original decimal position. And I can tell that I need to move this over a little bit. I didn't realize that I was not on the screen. My apologies. That number is the exponent. So if I'm going to put it here, this is the original position. So 1, 2, 3, 4. .8 times 10 to the 4th is the scientific notation form of 68,000. Let's do another number. $93 million. Again, I would write down that non-zero number and put the decimal right there. Then I'm going to count 1, 2, 3, 4, 5, 6, 7. So this is going to be 10 to the 7th. We can reverse this to write a number in standard notation. Remember from our definitions that standard notation is the way we normally write our numbers. So our problem is to write 3.5 times 10 to the 6th in standard notation. I'm going to take, this is where I'm starting from, I'm going to take my 3.5 and I'm going to write it down without the decimal in there. And let's put these notes over here on the side. You're going to write the number without the decimal. Then you're going to place enough zeros to move the decimal exponent times. Now, personally, I have another way of doing it. I look at this number, and I look at how many decimal places there are here. And I take the exponent minus that number of places, and that's the number of zeros that I'm going to write down. If we start here, then there's 1, 2, 3, 4, 5, 6, and it works. Let's try another problem. The number is 7.034 times 10 to the 9th. I'm going to write down the 7, 0, 3, 4. In my shortcut form here, 9 minus 1, 2, 3. So 9 minus 3 equals 6. If this works right, then I can put 6 zeros. And that will move the decimal the correct number of places that I need it. It started here. 1, 2, 3, 4, 5, 6, 7, 8, 9. It worked. That is what you are doing in today's assignment. And that is what we are ready for, is today's assignment. Summarize your notes. Set up 3 to 4 more pages. You may be getting far enough ahead that maybe 2 would be enough for tonight. And the actual assignment that you need to work, pages 36 to 38, numbers 1 through 15 odd, 16 through 31 all.